an overview of correlation. What is correlation coefficient and how we're going to use it to find the line of best fit. Suppose a safety inspector wants to determine if a relationship exists between the number of hours of training for an employee and the number of accidents involving that employee. Or suppose a psychologist wants to know if a relationship exists between the number of hours a person sleeps each night and that person's reaction time. How would you determine if there is a relation to begin with? In this section, we're going to talk about the type of relation between different types of variables, specifically quantitative variables or numerical variables. A correlation is a relationship between two variables. The data can be represented by ordered pairs x, y, where x is the independent or explanatory variable and y is the dependent or response variable. The graph of ordered pairs x, y is called scatter plot. In a scatter plot, the ordered pairs x and y are graphed as points in a coordinate plane. The independent or explanatory variable x is measured on the horizontal line or horizontal axis. And the dependent response variable y is measured on the vertical axis. A scatter plot can be used to check to see if a linear or straight line correlation exists between two variables or not. The scatter plots below show several types of correlation. Let's take a look. For example, in this case, you see as x increases from left to right, your y values start decreasing. Then the line that is representing this linear relation can be fitted here. This is the line that, as you can see, is a decreasing line. From left to right, you see there is a decrease in this line. Again, as your x increases, the y values start decreasing. In this case, we say that, hey, we have a negative linear correlation between x and y. Another one, as x increases in size, y start increasing as well. And from algebra, as you remember, here you have an increasing line. In this case, we say that we have a positive linear correlation. Positive, it means that the slope is positive slope. The rate of change is positive. So when we say that we have a negative linear correlation, it means that the slope of the line is negative. The rate of change is negative. It is decreasing. Let's take a look at this scatter plot. As you can see, there is no correlation. Here you see a bunch of points just going around without any pattern. So since there is no pattern, there is no linear correlation as well. However, here you have a pattern. The pattern is not linear, but we still see a pattern here. We say that, hey, we have a non-linear correlation. This is very similar to a parabola, but it is not a line. So we say that we have non-linear correlation. How do we construct this scatter plot? An economist wants to determine if there is a linear relation between countries' gross domestic product and CO2 emission. Let me change the color of my pen. The data are located on the left-hand side. So your x or independent or free variable is the list of GDP in trillions of dollars, 1.7, 1.2, 2.5, and so on. On the right-hand side, you have the CO2 emissions in millions of metric tons, which is denoted by Y, depends on X. So if X is 1.7, your Y is 552.6. If X is 1.2, your Y is 462.3, and so on. The scatter plot shown on the right-hand side represent these points. The smallest value here is 0.08, and the Y value for that is 253. So the very first dot, here you have 0.8, and here you have 253. If you match these two, you end up with the very first dot in your dot plot, in your scatter plot here. The next point is 1.2. When you have 1.2, it's associated to 462.3. So 1.2, which is just right here, and connected to 462, get your second dot in this scatter plot. So with the same discussion, you can grab the rest of these dots in your scatter plot. But take a look at the behavior, everybody. When you look at the behavior, you see that you have an increasing trend. As X increases in size, Y increases in size as well. If we do our best to fit a line here, this line is an increasing line. So we expect to see a positive correlation. Reading from left to right, as the gross domestic product increase, the carbon dioxide emissions tend to increase as well. So we expect to have a positive linear correlation between X and Y. But the question is how to measure that? What is the value associated to this correlation? How significant that value is? In the next example, we have a student that conducts a study to determine whether there is a linear relationship between the number of hours a student exercise and the GPA. So let's see, what do we have here? Let me change the color. So your X is the number of hours of exercise and Y is the GPA. So that student collected some information. The very first person has 12 hours of exercise with 3.6 GPA. The second person has 3 hours of exercise with 4 GPA. The third person has no exercise at all with GPA 3.9 and so on. So how do we visualize this? To visualize this, we have some dots, 0 and 3.9, the first dot. So 0 and 3.9. 0 is just right here, and 3.9, which is here. The next one is 2 and 2.2. Take a look at the data here. You have 2, your dot is going to be here. And then it goes up, goes down, goes straight, goes up, goes down, goes up again. So as you can see, there is no pattern here. What's the meaning of that? It means that the number of hours a student exercises each week doesn't appear to be related to the student's grade point average. No correlation here. There is no pattern to follow. So in previous example, we saw an increasing pattern. And here in this example, we don't see any pattern at all. Maybe we need to collect more data. What is correlation coefficient? Interpreting correlation using a scatter plot can be subjective. As you saw, sometimes from the data, we don't get a good information. Sometimes we need to collect more data. A more precise way to measure the type and strength of a linear correlation between two variables is to calculate what we call the correlation coefficient. Although a formula for the correlation coefficient is given down here, we are using technology eventually. The correlation coefficient is a measure of strength and the direction of a linear relationship between two variables. The symbol R represents the sample correlation coefficient. The formula is R equals to N times the summation of X times Y minus the summation of X values times the summation of Y values. On the denominator, you have 2 square root, everybody. Here you have square root of N times the summation of X squared minus the summation of X to the second power. And then in the second square root, you have N times the summation of Y squared minus the summation of Y to the second power. N is the number of pairs of data. So I expect you to ask, what if we have population and we are interested in finding the correlation coefficient for population? The formula is going to be the same, but instead of R, we're going to use a new symbol that is called rho. So the correlation coefficient for population is denoted by rho. When you read the homework or when you're hearing in the news, the correlation coefficient rho is equal to something, it means that they dealt with the population itself. Some information about correlation coefficient, everybody. The range of correlation coefficients is -1 to 1 inclusive. It means that it can be 1 or -1 in different cases. When X and Y have a strong positive correlation, R is close to 1. When X and Y have a strong negative correlation, R is close to -1. When X and Y have perfect positive linear correlation or perfect negative linear correlation, R is 1 or -1 respectively. Well, when there is no correlation between X and Y, then R is very close to 0. Take a look at this behavior here. Here you have a graph. The observation is that, well, let me change the color so I match it with the graph. As you can see, all of these points are lined up on a nice line. It means that R is equal to 1 and you have a perfect positive correlation. In this case, the data are just spread out a little bit, but still we can recognize the pattern. It's an increasing linear correlation. So instead of having perfect positive correlation, we say that we have strong positive correlation, and R by calculation is about 0.81. It's important to remember that when R is close to 0, it doesn't mean that there is no relation between X and Y. Just that there is no linear relation. For a weak positive correlation, in this case, you see it's going to be very difficult to recognize any pattern here. But still, if we pay attention closely, we see that there is a line passing through these. And here R is calculated to be 0.45 or 45%. And we say that we have a weak positive correlation. The line is still increasing. We see an increasing pattern. In this case, as you can see, we don't recognize any linear pattern. So we expect the correlation coefficient be around 0. And for these two, here you have a perfect negative correlation, or correlation coefficient is exactly -1. And here, again, we can recognize the pattern easily. You have a strong negative correlation, and R is -0.92. So different cases, different scenarios, you have different pattern and different values for your correlation coefficient. Steps in calculating correlation coefficient. First, find the sum of the x values. So whatever your list of x values, you need to add them all together. Add all x values. This symbol, sigma, means addition. Then you're going to add all y values together as well. Then what? You're going to multiply each x value by its corresponding y values and find the sum. So find the sum of x times y, square each x value and find the sum. So multiply each x by itself, then add all of those x squared together. The same process for your y. Multiply each y by itself and then add those together. And finally follow the formula. R, or correlation coefficient for your sample, is equal to n, the number of pairs that you have, multiplied by the summation of x times y minus the summation of x values times the summation of y values over square root of n times the summation of x squared minus the summation of x to the second times the second square root n times the summation of y values to the second power minus the summation of y's to the second. And then do the calculation to check to see if you have a strong, weak, or perfect correlation. Let's go back to our GDP in trillion of dollars and then CO2 emission. In calculating the correlation coefficient, if you add all of these x values together, it is 24.6. If you add all y values together, it is 5,263. But we need to do more calculations. Remember that in your first step, you're going to multiply x and y's together. 1.7 times 552.6 is 939.42. Then multiply x by itself. 1.7 times 1.7 is 2.89. Multiply y together. 552.6 times 552.6 gives you 305, 366.76. So this is for the first pair. What about the second pair? You have to repeat the process again. X times y, 1.2 times 462.3 is 554.76. X squared is 1.44. You multiply 1.2 by itself, and it is 1.44. You multiply y by itself, 462.3 times 462.3 is 213,721.29. And you do the same process for the rest of these values. So if you multiply x and y's, this is the list. And once you have all of these multiplication, you're going to add them together, the summation of x times y's. Multiply each x by itself, and then add them together to calculate the summation of x squared. Multiply each y by itself, add them all together to find this number, which is a large number, 3,412,308.32. Then follow the formula. in our formula, as you remember, on the numerator, you have n times the summation of xy's. We calculated the summation of xy's. What is n? N is the number of pairs that you have, minus the summation of x, which is just right here, times the summation of y's, which is this number, 5,263. And on the denominator, you have square root of n, which is 10, times the summation of x squared, which you calculated just right here, minus the summation of x values, which is 24.6, but you need to raise it to the second power, times the square root of n times the summation of y squared minus the summation of y to the second power. So let's do the calculation. 10 times 16,145.46 minus 24.6 times 5,263 divided by the first square root, 10 times 79.68 minus 24.6 to the second, multiplied by the second square root, which is 10 times 3,412,308.32 minus 5,263 to the second power, which gives us a nice correlation coefficient, which is 91.2%. So this is the result. Between the data, we did the visualization, we saw an increasing trend, but now we did the calculation. R is 91.2%, which suggests a strong positive correlation. The interpretation is, as the gross domestic product increases, the carbon dioxide emissions tend to increase as well. Now that we talked about the correlation coefficient, we want to know what is the best line representing that line passing through the points. After verifying that, you have a linear correlation between two variables and it is significant. The next step is to find that equation of the line that best models the data. This line is called regression line or line of best fit. And its equation can be used to predict, so this is the important part, to predict the value of y for a given value of x. Although many lines can be drawn through a set of points, a regression line is determined by specific criteria. Consider the scatter plot and the line shown below. For each data point, d sub I represents the difference between the observed y value and the predicted y value. The observed y value is the actual y value. The predicted y value is the value coming from the line itself. So as you can see, there is a difference between the observed value and predicted value. They are not necessarily the same. We call that the residual. These differences are called the residuals. Our job as statisticians is to minimize the sum of the squared residuals. And it can be positive, negative, or zero. When the points are above the line, d sub I is positive. Like these points, observed value is more than the predicted value, so their difference is positive. The observed value is more than the predicted value, so their difference is positive. The observed value is more than the predicted value, so the difference is positive. It can be negative. Like this case, the observed value is smaller than the predicted value, so their difference is negative. The observed value is smaller than the predicted value, so their difference is negative, and so on. When the point is below the line, di is negative. When the observed value equal to the predicted value, the residual is equal to 0. Of all possible lines that can be drawn through a set of points, the regression line is the line for which the sum of the squares of all residuals is minimum. So this is our goal. Our goal is to find the equation of the line which has the sum of the squares of all residuals to be in the minimum value possible. So let us begin. A regression line, also called a line of best fit, is the line for which the sum of the squares of the residuals is minimum. In algebra, you learn that you can write equation of a line by finding its slope, m, and y-intercept, b. Then the equation can be written as y equals to mx plus b. For example, take a look at this line. You can easily find the slope of the line, which is rise over run. Rate of change is 2 over 1 or 2. To find the y-intercept, which is this point here, you simply substitute 0 for your x, and b, or the y value, becomes 1. Recall that the slope of a line is the ratio of its rise over its run, and the y-intercept is the y value of the point at which the line crosses the y-axis. It is the y value when x is equal to 0. So again, in this case, you have slope, which is equal to 2. The rate of change is 2. And 1 is your y-intercept. It is your b. But to graph any line in algebra, you just need 2 points. When it comes to statistics, we have many points to work with. That's why we are interested in calculating the slope and y-intercept for a regression line when the sum of the squares of the residuals is minimum. Let's take a look at one example together. First off, what is the formula to calculate the slope and y-intercept? The equation of a regression line can be written as y hat equals to mx plus b. So when you see y hat, it means that it's referring to the regression line. Now, y hat is the predicted y value for a given x value. It's not necessarily the actual y. It is the predicted value. The slope m and intercept b can be measured using the following formulas. M is equal to n times the summation of x times y minus the summation of x times the summation of y divided by n times the summation of x squared minus the summation of x to the second power. And b is y bar minus m times x bar, but y bar is nothing but the average of y values, and x bar is the average of x values. Again, y bar is the mean of the y values, and x bar is the mean of x values. N is the number of pairs of collection of data that you have. The regression line always passes through the point x bar, comma, y bar. We're going back to GPD and CO2 emission example and calculating the regression line. Remember that you had your x values and also your y values. To calculate the mean and do the calculation for your slope, you just need to basically add all of these numbers together and divide it by, remember you have 2, 4, 6, 8, and 10. So by adding all of these values together and divide by 10, you find your average x values. To find the average of y values, you do the same thing. You add all of these numbers together and divide it by 10. Punch all of those into this formula. N is 10. You already calculated the summation of x times y, which is equal to 16,145.46. The summation of x values is 24.6. The summation of y values is 5,263. On the denominator, again, n is 10. X squared, all added together, is 79.68. And sigma x, which is the sum of all x values, is 24.6 raised to second power. So m, or the slope of the line, is positive. It is 166.938. Now for the y-intercept b. Remember, the formula was y bar minus mx bar. Y bar, which is the average of your y values, and your x bar, which is the average of your x values. Perfect. Y bar is 5,263 divided by 10. And your x bar, which is the average of x values, is 24.6 divided by 10. When you do the calculation, you have your m coming from previous calculations. So you just write it here. It is about 115.725. This is the graph of your regression line. And as you can see, it passes through x bar, comma, y bar. From the slope of the line, you have a positive slope. And as you can see, the line is increasing as well. And this is your y-intercept, which is 150.725. So if I ask you to write down the equation of your regression line, you're going to write y hat equals to m slope of the line times x plus b. So again, we need to follow these formulas to do the calculation for m and b. Then you punch them here, and then your y hat, or the regression line, can be written as 166.900x plus 115.725. And this is the visualization.